Math 3, Unit 3, Section 1. Today we are talking about the end behavior of graphs. So there are lots of different graphs and functions, and so we're going to talk about their end behavior and how to draw them. Okay, the first thing is the degree. Okay, the degree of a polynomial is the highest exponent in the polynomial. Okay? You have to be careful because not all functions are written in descending order. Okay? So if we look here, what is the highest exponent of this first one? 5. So the degree is the value of the highest exponent. So in this case, the degree would be 5. Okay? On the g of x equation, what would be the degree? Very good. 3 is correct. And on the h of x equation, what would the highest exponent be? Yeah, so if there isn't an exponent there, but we have a variable, it actually has a degree of 1. Okay. The next thing we're going to talk about is the leading coefficient. Okay. First of all, what is a coefficient? Very good. The coefficient is the number in front of the variable. Okay, so your leading coefficient is coming from the same term as your highest degree. So looking at the same f of x equation, the leading coefficient would be what? 3. The leading coefficient comes from the term with your highest exponent, so 3. And more importantly to know is that this is actually a positive number. Okay? It's going to be helpful as we go through this. Okay, on the g of x equation, what would be my leading coefficient? Very good. Again, it goes with your term that has the highest degree. Okay, and so this leading coefficient is actually negative 5, and specifically knowing that it is a negative number. And what would be the leading coefficient of the h of x equation? Very good, 2. And then that one is a positive number. Okay, the next thing we're going to talk about specifically is the end behavior. The end behavior of the graph of a function describes the value of f of x at the far right and the far left of the graph. Okay, so there are 4 different ways that graphs can go. Okay, the right side here is going to positive infinity, the left here is going to negative infinity. Here, both the left and right are going to negative infinity. See how they're going down? Negative infinity. Here, the left is positive infinity, the right is negative infinity. And here, both are going to positive infinity. Okay? This next part, and all this is going to come together. We're just talking about each piece. You're going to be okay. Describe the end behavior of the following graphs. So we are going to describe what's happening. Okay? The end behavior on the right and the left here, since the arrows are going up, the right end behavior is going to positive infinity, and the left end behavior is also going to positive infinity. When it says describe, that means they want you to write a sentence in words. So that's all we're going to do. Okay? I'm going to write this out. On the left and right, f of x goes to infinity. Okay, the next graph, if you look here, the right side is going where? Negative infinity because it's pointing down. And the left side is going to positive infinity. Very good. And so again, we're going to go ahead and write a sentence. So on the right, f of x goes to infinity. Yes, candy for you. On the right, f of x goes to negative infinity. On the left, f of x goes to infinity. Okay. Next page. So now we're going to look at these graphs. If you were to like plug this graph into Desmos right now, it would make this picture, okay? So we have the written equation and we have the graph that goes with this equation. And we're going to try to figure out what's happening and if we can make some, kind of some rules for the different information that we have. So if we look here, okay, first of all, what is the degree on this problem? 3. The highest exponent is 3. Do we agree? All right. The leading coefficient comes from the number in front of our highest exponent, right? And so what would that leading coefficient be? 1. And specifically, we want to know that it is positive. And I'm just going to start doing a plus sign and a minus sign instead of writing positive and negative. Okay, if we look at our end behavior, we always start with our right end behavior and then we do the left end behavior. And on the right side of the graph, it's going where? To infinity. And on the left side, it's going to negative infinity. Very good. Okay, so we're going to go and do the same thing now for this next one. So first of all, what is my degree? Nope. The degree is 3. The leading coefficient is negative 2, and specifically it is negative. My right end behavior is going where? Down, which means negative infinity. And my left end behavior is going to positive infinity. Is anybody confused where any of this information is coming from? Okay. We're going to do this next one together. Okay, so looking here, what is my degree? 2. What is my leading coefficient? Negative 1. And again, specifically, we're going to put that that's negative. And then my end behavior on the right side is going where? Right side is negative infinity, and left side is negative infinity. Okay, do we have questions? All right, I want you guys to do these next ones on your own. Okay, and I'm going to pull some sticks and call in some names for you to help me. Okay, so do them in your groups. I'm going to give you about a minute and a half or so. And you can check in your groups if you guys are correct. If anybody has a question, raise their hand right now and I'll come by and answer it for you. All right, it looks like most of you are almost done. Okay, so first thing is I'm going to call on, I'd like this person to tell me of this problem, the degree and the leading coefficient. So, okay, let's take our test. Leanna, can you tell me what the degree is and the leading coefficient?
The degree is 4 and then the leading coefficient is...
Perfect. Okay, now I need the next person to tell me the right and left end behavior. So please help me out, Devin.
Of course. Infinity and left there's negative infinity.
Very good. Thank you. Okay, any questions on this one? Okay, next problem. Help me out. Isaac, can you please tell me the degree and the leading coefficient?
Degree is 5, leading coefficient is 1.
Perfect. Degree is 5, leading coefficient is 1. And then, Kylie, can you tell me what's happening with my right and left end behaviors? Perfect. Right is positive, left is negative. Well done. Okay, next one. Bella, can you tell me my degree and leading coefficient? Perfect. Degree is 4, leading coefficient is 1. And my end behavior, Sydney? Very good. The left and right are both positive infinity. Okay, so now I'm going to give you a minute, in your groups. And I want to see if you can notice anything that's happening. Like, this is always true. If the degree is even, this always happens. Or if the degree is odd, this always happens. So in your groups, you can talk about it here for a minute. Just look at those graphs and see if you notice anything to be true all the time. Okay, I heard Victoria say something, so I apologize for putting you on the spot. But Victoria, what did you say to your group?
I said if they're even, they're either both positive or both negative.
Very good. Okay, so if you guys look here, so we're looking at the degrees. Do you see how here's an even degree, they're both going down. Here's another even degree, they're both going up. Here's another even degree, they're both going down. Okay, now if it's an odd degree, what do you notice? One's positive, one's negative. So odd degrees are opposite. You know how odd starts with O and opposite starts with O? So I remember that odd is opposite directions, and then therefore even is the same. So if you go right down here, this is what we were talking about. Left and right and behavior on all even degrees. And Victoria told us that they go in the same direction. Okay, now the left and right end behaviors for odd degrees, those go in opposite directions. Okay, and then this is kind of giving us a clue here, but this says the right end behavior with polynomials with a positive leading coefficient go which direction? So let's go look. Look at all the leading coefficients that are positive. What happened to the right end behavior on all of them that have a positive lead coefficient? I heard it.
They go up.
Yes. So if you look, all of the leading coefficients, if it's a positive, it doesn't matter odd degree or even degree, all of the positives go on the right side, go to positive infinity. So here it is, goes to positive infinity. What about all the right end behavior of negative leading coefficients?
Negative.
Exactly, negative infinity. And this is true for the graphs of all polynomial functions, okay? So the first thing you always start with is your leading coefficient. If your leading coefficient is positive, the right side is going to go to positive infinity. If your lead coefficient is negative, the right side is going to go to negative infinity. And then based on if it's even or odd, the left side will either go in the same direction or the opposite direction. So now we're going to practice. Now that we know this, we're going to practice on these problems below. Okay. So now you don't have the graph to look at. We're looking at this without the graph. Okay, what is the degree of this first polynomial function?
6.
Very good, it is 6. Okay, what is the lead coefficient? 0.2, and specifically we know that is positive. So, because the lead coefficient is positive, my right side will go up, which means positive infinity. Because it's an even degree, Evens go in the same, so therefore the left will also go to
Infinity.
positive infinity.
Okay.
Okay, next one. What is my degree?
5.
Very good. My degree is 5. That's my highest exponent. What is my lead coefficient? Good, -1. And specifically that is
Negative.
negative. Because my lead coefficient is negative, my right end behavior will go where? Negative infinity. Very good. My left end behavior is going to go where? Positive infinity. Why?
Because it's the opposite.
Because it's the opposite. Odd numbers go in opposite directions, so the left goes to positive infinity. Ask me.
I thought it's the same when it's.
No, odds are opposite.
Oh, wait,
Odd
yes.
opposite, evens are same.
Mess up.
Yes.
I'm lost.
Okay.
How you got that? Because like the other problem, they're both the same.
So even degrees, you know 6 is an even number?
Yeah.
Even degrees will go in the same direction. Odd degrees go in opposite directions. Odd opposite. And then you always get the right behavior from your coefficient being positive or negative. So we always start with the right side, and then we know the left side based on the degree. Okay, so let's try this next one. And I'm going to just pick on you because I want to make sure you get it. Okay, you ready, D'Angelo?
Yeah.
Okay, so what's the degree on this next one?
2,
2. What is my lead coefficient?
1,
No. So your lead coefficient always comes from the number with your highest degree.
-3.
Good, -3. And specifically, we know that that's negative. Because my lead coefficient is negative, what is my right end behavior going to be?
So if the x by itself, you just leave it alone. It wouldn't be like 1 or anything.
Say that again, if the exponent's what?
If the exponent is alone, it wouldn't be like.
The degree would be 1. But in a problem, to find your degree, it's always the highest exponent. So no matter what order it's in, you go and find the highest exponent, and that's what your degree is.
Okay.
Okay, so because my lead coefficient is negative, my right end behavior will be what?
Negative.
Very good, negative infinity. Okay, now my degree is even, and even means that they're going to go in which directions?
The same.
The same, so that means the left is also
Negative.
negative infinity. Okay, is that better? All right, you guys ready for me to pull some 6 for this next problem? Okay, so please tell me the degree. Oh, she's on her customer. Oh my goodness, Noah. Okay, Wyatt, what is the degree?
1.
Very good, the degree is 1. So notice my highest exponent there is 1. Okay, my lead coefficient is what, Michelle? -1, good. My right end behavior. Now this, I want you to tell me what the right end behavior is and how you know it. Are you guys ready? Okay, Michael, what is my right end behavior and how do you know it? And that is correct. And how do you know it's negative infinity?
Because it
Because the lead coefficient is negative. Okay, now my left end behavior, I'm gonna pick on somebody else. Dylan, what's my left end behavior going to be on this problem?
Gonna be infinity.
Very good, positive infinity. And how do you know that?
Because it's even odd.
Odd degrees, opposite directions. Very good. Okay, next one. I want somebody to tell me the degree. Melissa, what is the degree on the next one?
3.
Very good. 3 is correct. Highest exponent. Okay, what is my lead coefficient? Oh my goodness. D'Angelo, what's my lead coefficient?
4.
Very good. Okay, my right end behavior and y. Right end behavior and y. Carrie.
Your right end behavior is negative and positive infinity
How do you know?
because it's a positive.
A positive lead coefficient. Good. Positive lead coefficient. Right side is positive. Okay, my left end behavior is what and why? Jason. What's my left end behavior and this going to be and why?
Positive. Negative infinity?
Do you know why?
Really?
Okay, so do you see this number 3?
Oh, it's because it's off.
So your left end behavior comes from your degree. So if it's odd, it's going to be the opposite of what the right was. If it's even, it's the same. Okay? Is that better? All right. Next one. Please tell me the degree. Lily, what's my degree?
4.
Very good. 4 is correct. And my lead coefficient is what? Rena? 2. Good. 2 is correct. And that specifically is a positive number. Okay. Now, next, please tell me what the end behavior is and why. Brent?
To the right is positive equal
Good. Very good. Do you want to go and tell me the left too?
The left is positive infinity.
Very good. Okay, so our right end behavior comes from our coefficient, and our left end behavior comes from our degree. Do you have any questions for me right now? Okay, we're going to go ahead and turn the page. Okay, so this says identify the end behavior. So number 1, identify the end behavior. Number 2, we need to justify our answer. Okay? So just like on the previous problems, we are going to state our degree. We are going to state our leading coefficient. We're going to state our right end behavior and our left end behavior. Okay, so even though it said just to state the end behavior, in order to know what the end behavior is, I have to know my degree and my leading coefficient. When it says justify, we are going to explain in words how we know all of this stuff to be true. Okay, so please tell me, Nick, what is my degree?
3.
Very good. And can you also tell me what my lead coefficient is? 8, and specifically we know that is a positive number, which is helpful. Okay, now right end behavior is what, Kat? What is my right end behavior?
Positive.
Very good, positive infinity. And how do you know that? How do we know that, Kat?
Negative.
No,
Positive.
positive infinity. And how did we know? It's because the
Number is positive.
the leading coefficient is positive. Okay, there we go. All right, now my left end behavior is what and why? Reef.
The left is negative infinity
Good. And how do you know that to be true?
because it has a negative, or it's a odd degree.
Very good. Negative because it's odd degree. Odd degree means opposite. Okay, so we're going to try to write this in words, right? So I'm going to start with, on the right, everybody write this down. On the right, f of x, good, goes to infinity because why?
Because the leading coefficient is positive.
Because the leading coefficient is positive.
Very good. Because the leading coefficient is positive. Okay, now on the left, f of x goes to negative infinity because, somebody finish the sentence for me.
The
Degree is
Very good. Because the degree is odd. So we know this is the correct answer for our end behavior, and we have justified this right here explaining everything. Okay. All right. Now we're going to go the other side. Okay, what is, we need to figure out, just like we did before, our degree, our leading coefficient, our right end behavior, and our left end behavior, and then we are going to justify it. Okay, what is my degree? Very good, 6. Does everybody agree that that's our degree? It's the highest exponent there in the problem. Okay, what is my leading coefficient? -1, and specifically we want to make a note that that is a negative number. Okay, so now I'm going to pull another stick. Please tell me what my right end behavior is and why. Okay, Faith, what is my right end behavior and why?
It's negative infinity because leading coefficient is negative.
Very good. Okay, right end behavior is negative infinity because my lead coefficient was negative. Okay, left end behavior. Brady, what's my left end behavior going to be and why? Perfect. Left end behavior is negative infinity because the degree is even, which means they go in the same. So now we need to justify this. We need to put this in words, what is happening and how we know it. Okay? So, I'm writing it one way. As long as you're giving the information in your own words is fine. Okay? So, I'm going to put the left and right and behaviors, or end behavior, and behaviors, I don't know, and behaviors go to negative infinity because the leading coefficient is negative and the degree is even. Do we have any questions there? Okay. Next part. It says identify whether the function graph has an odd or even degree and a positive or negative leading coefficient, and then we have to justify. So if we were to go through, and I actually have been teaching my children this at home, to read the question, figure out everything they need. So I need to identify if it's odd or even. I need to state whether the leading coefficient is positive or negative, and I need to justify. So there are 3 different things that I need to do. Okay, make sure that you're numbering and figuring out that you answer every part of the question. Okay, so in order to figure out this stuff, we're going to go ahead and write, just like we did in all other ones, our degree, our leading coefficient, our right end behavior, and our left end behavior. So on this one, because I don't have numbers, I'm going to start with just stating what my end behavior is. Okay, so what is my right end behavior based on this graph? Okay, and my left end behavior is what? Okay, because these are opposites, what do I know about my degree? It's an odd. And that's all they asked us. Is it odd or even? They didn't say to state the specific number, but because these are opposites, we know it's an odd degree. My lead coefficient is going to be what? Negative. And how do I know that? Because my right end behavior is negative infinity. Now, they said to justify our answer, which means we need to write a statement. So we have the information. All we're going to do is write how we know this information here to be true. Okay? And I'm going to start using some abbreviations as I write. So the first thing I'm going to put is the lead coefficient, but I'm going to write that as LC instead of lead coefficient, is negative because why? How do I know the lead coefficient is negative? Very good, because the right, and I'm going to put EB for end behavior, because the right end behavior goes to negative infinity. The degree is odd because why? Good, because I'm going to put because the left and right end behavior, or EB, go in opposite directions. So you guys verbally told me all of this. When you're justifying, you just have to write down how you know the answers to be true. Does that make sense? Okay, so we're going to do another one here. So again, we have our degree, we have our lead coefficient, our right end behavior, and our left end behavior. So when we are looking at this graph, my right end behavior is what? Positive infinity. My left end behavior is what? Positive infinity. Okay, so based on them being in the same direction, we know what about the degree? Even. So same, when it's going the same way, we know it's an even degree. And my lead coefficient is what? Positive, and we know that because why? Because the right end behavior is positive. Okay, so we're going to write another sentence using some abbreviations. The lead coefficient is positive because, why? Tell me. Because the right end behavior is, or goes to positive infinity, or up, that's fine. Okay, and then we would say the degree is even because the left and right end behaviors go in the same direction. Very good. Sorry. Do we have any questions there? Do I need to explain any of my handwriting? Okay. Next it says, give an equation of a polynomial f of x with end behavior on the left going to negative infinity, and on the right it goes to negative infinity. Okay, so I'm going to go ahead and write this all down again. We have our degree, we have our leading coefficient, we have our right end behavior and our left end behavior. So right here, they told me that on the left here, it's negative infinity. On the right, it's negative infinity. So based on that information, what is my lead coefficient going to be? My lead coefficient is going to be positive or negative? Negative. And how come it's negative? Because the right end behavior is negative. Okay, degree is going to be what?
Even.
Even. And it's even why? And behaviors are the same. Okay? Odd degrees are opposite, even are the same. So, because they said f of x, our equation should be f of x equals, I know my lead coefficient needs to be negative. Any negative number I can write. Okay, negative 2. And then my degree needs to be even. X to the 6th. Okay? I can write anything else after this that I want to as long as all of the exponents are smaller than 6. So like this could be my answer right here. Or I could also have like minus 5x to the 4th plus 2x to the 3rd plus 1. It doesn't matter because all that matters is that my lead coefficient is negative and that my highest exponent is an even number. Could it have been negative 2x to the second and then not had anything else here? Yes, as long as your highest exponent is even and your lead coefficient is negative. Okay, so there are an infinite amount of answers. Okay, next one says, give an equation of a polynomial with n behavior. On the left side, g of x goes to negative infinity, and on the right side, g of x goes to positive infinity. Okay, so again, I would write everything out. We have our degree, our lead coefficient, our right end behavior, and our left end behavior. The right end behavior is what? Positive infinity, good. The left end behavior is? Negative infinity. Okay, based on this information, what degree would this be? Odd. How do I know it's an odd degree? These are going in opposite directions. My lead coefficient should be what? Positive. And I know it needs to be positive. Why? The right end behavior is positive. Okay, so we can write any equation. We just want to write it as g of x. We know that our lead coefficient needs to be positive, so I'm just going to use 5. You could use 1. You could use any number you want as long as it's positive. And it needs to be an odd degree. I'm just going to use x. Is that an odd degree?
Yes.
Yeah. Could I have written x to the third?
Yes.
Yes. Okay. So multiple answers there. Any questions? Okay, let's go ahead and turn the page. All right, so this one says, sketch a graph, positive lead coefficient and an even degree. Okay, so we have our degree, we have our lead coefficient, our right end behavior, and our left end behavior. They said that it's an even degree, so I'm going to write even here. Lead coefficient is positive. Based on this information, my right end behavior is going to be what? Positive infinity, and my left will be positive infinity. We knew the right because the leading coefficient was positive. We know the left because even degrees go in the same direction. So if I am doing a graph, I know that on the right side it's going to positive infinity. On the left side it's going to positive infinity. And in between, you can basically do anything that you want. Okay? It could have just been like a quadratic. It doesn't matter. Okay? We're only worried about our right and left end behaviors right now. Okay. I'm going to give you about 30 seconds. I want you to sketch this one. Do this one on your own. See if you can get it right. Do I have a volunteer to come up and do this problem? Okay, Michelle, come up. You can do it. You can just write it down. I'll talk through what you're writing.
You're gonna write it.
Okay, Leanna to do it.
Come on, Leanna.
I know.
Leanna.
Okay. So it's an odd degree because it says so.
Good.
I don't care.
Okay.
I'm just
She said
kidding.
odd degree because it tells us.
Okay, and then the leading coefficient is a negative because it's.
Uh-huh.
Oh my. Because it
Guest
says
speaker,
so.
Michelle.
Okay. And then since the leading coefficient is a negative, the right, what is this called? The
Right end behavior.
right end behavior would be a negative.
Good.
And since it's odd, it's gonna be the opposite of the right.
Perfect.
Okay, so yeah.
Perfect. Okay, and again, it could be anything in between as long as on the left it's positive infinity, right is negative infinity. Yeah, you get candy. Any questions? Okay, next one.
See, you did it.
This says, determine the degree of the polynomial in factored form, and then demonstrate you are correct by writing the polynomial in standard form. Standard form is when it is multiplied out. So right now it's in a factored form. Multiplied out is standard form. So how this works is each of your factors, you take their degree, their highest degree. So the highest degree of this first factor, the first parenthesis, is 2. The highest degree of the second one is x to the third. Do you see that? And so that means that the degree for this polynomial, you would add each of those highest exponents together, and the degree of the problem should be 5. You would also, for the lead coefficient, you would multiply each of the exponents, or sorry, not each of the exponents, each of the coefficients in front. So this lead coefficient, you'd end up multiplying 1 times 1, which gives you 1, or a positive number. To check this out, to see if it's actually true, you could multiply it out. And so we would distribute. X squared times x to the third gives you x to the fifth, because when you're multiplying with exponents, you add them. X squared times negative 5x squared gives me negative 5x to the fourth. X squared times 2x is 2x to the third. Negative 4 times x cubed is negative 4x cubed, and I'm just lining up my like terms. Negative 4 times negative 5x squared gives me positive 20x squared. And negative 4 times 2x is negative 8x. And so when you bring this down, we get x to the fifth minus 5x to the fourth minus 2x to the third plus 20x squared minus 8x. This is now in, standard form. I know, I'm sorry. This is standard form. And you can see that we did get the same degree of 5 and lead coefficient of positive 1. But looking at it like this, I think, is way easier than having to multiply it all out into standard form. Okay? So, could you guys figure out what the degree is of this one? Well, see how it's in factored form? You have to take each factor, okay? And if you look at this one, because it's to the second power, there's actually 2x minus 3s. Do you guys agree? And so the degree of this problem would be what? 7 is correct. Because this is a 4, this is a 1, and this is a 1, but there's really 2 of those 1s, correct? And so 4 plus 5, 6, 7. The degree is 7. The lead coefficient would be 1 times 1 times 1 squared, which is 1, which is positive. And we could multiply all this out, and we would see that the degree is to the 7th power, but we're going to go ahead and stop there and not worry about that.